Alright guys, welcome to this page of the notes. Now that we've taken care of that first objective, which was understanding the relationship between relations and functions, and looking at the 4 ways to represent a relation, and then determining if the relation is also a function, which means it has to pass that one-to-one test. We can also determine if it is onto. Now we're going to start to look at this idea of the graphs of relations and functions. So here's what we're going to take a look at here. Now what I want to point out is, first of all, when it comes to a discrete relation, I don't want my marker, I want my highlighter. Let me get you the highlighter. Right here, this discrete relation. What this is going to be is a discrete relation is always going to be a set of ordered pairs. You are just plotting points. So these will always be ordered pairs. A discrete relation is ordered pairs. Ordered pairs. All right, this continuous relation, we're not going to call it a continuous relation. Whenever you can draw a line, it is always going to be a function, and that's going to be represented by an equation. So these are going to be functions. Hang on, you can't read that. That's no good. Let me try again. There we go. Here's my marker. It's going to be a function. And a function is always going to be represented by an equation. Always can be represented by an equation. So you will have either a discrete relation, which will be ordered pairs, or you'll have a function, which is going to be a line. You're going to be graphing a line, and that will always be represented by an equation. So let's go ahead and take a look at what this is going to be. So we come right down here to our first example, and what you've got is you've got both. Here in part A, I have a set of ordered pairs. Right away we know, hey, it's ordered pairs. That is going to be discrete. So we know that this first one is discrete. When I graph it, I am just going to have a bunch of dots. Well, let's go ahead and do that. Let me make my dots a little bit bigger here so you can see them. Here we go. My first one is going to be at -4, 2. So I'm going to count over 1, 2, 3, 4 in the negative direction, and then -2, down 2. 1, 2, 3, 4, down 2. I get right there. So there's my very first dot right there at -4, 2. -2, 1. 1, 2, +1. There's my next dot right there at -2, up 1. And then 0, 2, 0, up 2, 0, up 2. And what I've got is just 3 dots. They are not connected by a line. They're represented by ordered pairs, and this is a discrete relation. This one, part B, is an equation, and we just said above, anytime you have an equation, it represents a function. It will always be continuous. So this is continuous. Nope, sorry, hang on, I apologize. That's way too fat. Let me fix that. Here we go. This is continuous. And here's the way that we're going to do continuous. Please remember from Algebra 1, the way that you can graph these, the simplest way is to set up a table or a chart. So let's go ahead and do it that way. The way the table or chart works is you're simply going to set up an XY table, X, Y, and we're going to choose values of X that I will plug into my equation to get out the Y values. And the trusty old ones, right? Work smarter, not harder. Start with -2 and go all the way to +2. Those are the easiest ones, right? 2s, 1s, and 0s are easy to do math with, right? We're not picking them because they're special. We're picking them because they're easy. So -2. They may not always work, but it's a great place to start because it's easy math to do. You're not really wasting too much time. Those are easy numbers to work with. So that's a great place to start. Here we go. I plug a -2 into my equation for x, and -2 plus 1 is going to be a -1. So that's my y value, -1. I'm going to plug a -1 in for x. -1 plus 1 would be 0. I plug a 0 in for x. A 0 plus 1 is going to be a +1. I'm going to plug a 1 in for x. 1 plus 1 will be 2. And I plug a 2 in for x, and 2 plus 1 should be 3. Now what I've got is a bunch of ordered pairs that I can now graph as well, but remember this is an equation, so we're going to connect those guys with a solid line. Let me do it in, let's see, I already used red, let's do this one in green. Alright, here we go. Let me plot my points. My first one is going to be at -2, -1. -2, -1, so right there. And then I'm going to have -1, 0, -1, and 0, and then 0, 1 right there. 1, 2, 1, 2, and 2, 3, 2, 2, 3. Connect those with a line. And it should look something, hopefully you get something that looks like this. When you graph an equation for me, runs right through there. When you graph an equation for me, please make sure that you extend your graph, your line, your function, your equation, all the way through the coordinate plane that I have given you, all right? Please don't just connect the dots that you've plotted and stop there. Don't do that. Please extend your line all the way through the coordinate plane. I will be looking for that on quizzes and tests. And make sure that you put arrows on the end of your line, because your line doesn't just end. It does continue. It keeps going. We could put more values into my table and find more that I just don't need to. I connect those points with my line, and I know that it'll just continue to infinity in that direction. Continue to infinity in that direction, so please make sure you put arrows on it. Let's head on over to the next page and take a look at now that we're graphing, right? How do you determine if the graph represents a function? Because not all graphs are going to represent functions. So here we go. You should remember from Algebra 1 what we call the vertical line test. Now, here's what we're doing when you do the vertical line test. Remember, when you guys had a map, what you were looking for was that one-to-one test on the map. Does every value in the domain go to exactly one range value, all right? You can't have a domain value going 2 places in the range, right? Every domain value must go to one range value. Well, that's exactly what you're doing here, but instead of calling it the one-to-one test, it is the vertical line test. Let me show you how it works. Right here we have a function. Let me highlight it for you, the vertical line test. Vertical line test. And what you're checking to do is this. A relation is a function if and only if a vertical line intersects its graph, right, at only one spot, right? It cannot intersect it more than one spot. So here we go, what we're going to do. I've got this first one for you, and they've drawn a vertical line, and please notice that my domain value is this guy right there. Right there's, oh, hang on, that's my highlighter. I don't want that. I want my marker. Is this point right here, which for them is the point -1. Now, when I draw my vertical line at -1, how many times does it cross my function, my graph? Well, it only crosses at one point right here, which looks like it is at y equals -2. Now, if I were to have a map of this, what I would have on my map would be -1, which is my domain value, and -2, which is my range value, and -1 only goes to -2, right? Because there's -1, it only goes to -2. I don't have that vertical line crossing my graph anywhere else. It only crosses right there, and so this passes the one-to-one test. This domain value only goes to this range value. I pass the one-to-one test. Let's check the other one though. Well, on this one, now I am at the domain value of a +1. My vertical line has been drawn right here at positive 1, right here, positive 1. But when I draw my vertical line, it actually crosses the graph twice. It crosses right here, which if you look closely on your notes or on the screen there, looks like it's at a positive 1.5. But it also crosses down here at what it looks like is a negative 2. So in this case, if I were making a map, my domain value, which is a positive 1, actually goes to two range values, a positive 1.5 and a negative 2. Those are my range values. Well, what we said is that a function must pass, or in order to be a function, it must pass the one-to-one test, which means each domain value can only go to one range value, and it doesn't. This fails the one-to-one test. It fails the vertical line test. So here's the point. This guy right here, this vertical line test is the one-to-one test for relations. It's just now we're doing it on a graph, so we call it the vertical line test instead. This is the one-to-one test for a graph. This is the one-to-one test because it's on a graph. We don't call it the one-to-one test, we simply call it the vertical line test, even though you're testing the same thing. Does each domain value go to just one range value? We just don't call it the one-to-one test, we simply call it the vertical line test. But the point, you're doing the exact same thing. When you're doing the one-to-one test for a map, you're doing the one-to-one test here, just now it's on a graph, so we call it the vertical line test. Go ahead, head over to the next page of the notes. We'll get a little bit of practice with this vertical line test, so I'll meet you there.